So as we look at this flow of our immersed body, we have to ask ourselves, what kind of forces are we dealing with? Now, these forces don't matter if they're a liquid or a gas. The properties of these fluids will determine the magnitudes of these forces. So for this discussion, we're just going to look at an airfoil. And we're just going to look at a 2D flow situation. Not as fun as a 3D flow, but it's going to get most of the point across. And we have two very large things that are driving forces on a body. The first would be pressure. As we push this through a fluid, you're going to get a pressure buildup. And in fact, this chart shows you right here in the front, we will get a positive pressure pushing down. Along the bottom, we will have a positive pressure pushing up. And then along top of the airfoil, we're going to have this negative pressure. So it's much less than what's on the bottom. The next thing that we have, so that's our pressure forces. The next driving thing that we have are the shear forces. And so that's all of our friction in the airfoil, all the friction in the fluid as it flows over the airfoil that is kind of retarding the motion. And so this is a shear stress. So if you look at it, we'll go back here. We have these pressure forces. Most of the ones pushing in the in the x-axis are there. Most of the rest of them are in the y-axis. And then as we look at this one, except for a little bit right here, most of the shear forces are going to be in the x-axis. But we can add these forces together. We can superimpose them on top of each other and calculate out resultant forces. And the resultant forces will have a resultant x and a resultant y. And so once we do that, typically these are depicted as cursive capital D, cursive capital L. And so we're going to call these forces the lift and the drag. My capital cursive D has never been very good. So lift and drag forces, that is what we're going to be dealing with. So lift forces basically represent forces that will allow an airfoil or a hydrofoil to ascend, as long as, and of course, if you flip it upside down, it pushes down, but we'll talk about that later. And drag forces are the ones that are going to retard the motion, that's going to pull back on the plane. So let's talk about these viscous forces in the drag direction, and let's look how fluid flows past a flat plate.